So I'm just going to launch the engine and create a brand new project. First person shooter template, and we'll call it while running tutorial. Everything else default. This is just going to be a brand new project. We're going to start from scratch. So now that we have a fresh project, go ahead and open up your first person character. Now we're not actually going to do any code in here, just a setup for our component. So we're actually going to do all of our code in a component class. So create a new folder, components. Now in here, create a new blueprint. It's going to be an actor component, and we'll call it Parkour movement. Now we can go back to our first person character. We can add this, and now any code we do on here will actually work on the player character without us having to actually do code in there. So now that we have the Parkour movement component set up, we'll need a reference to our character. To do that, create a custom event, call it initialize. Now from here we can pass in a reference to our character. This will be of type character object. We can right click, promote this to a variable, call it character as well. We'll also need a reference to the character movement component. We can get that from the character. We can do the same thing here, promote this to a variable, call it character movement. Now, since we're going to be messing with the gravity, we're going to want a way to set it back to default. So we can get a reference to the gravity scale here from within the character movement component. And then we can promote this to a variable and save it as default gravity. Next, we're going to need to call this initialize function in our first person character. So I'm going to open that back up, find the event begin play node, and I'm going to use a sequence here. So after this code is called, we're going to go ahead and call our initialize function. And we can pass in a reference to ourself. So now we're passing in a reference to this first person character blueprint to our Parkour movement component. Now there's two more events we're going to need. We're going to need a land event, and we're going to need a jump event. Similar to the initialize function, we're going to go ahead and call these from first person character. So we're going to need to find the jump event. Here it is. And we're going to call the jump event on the Parkour movement component. Now for the land event, we're going to have to search for it. There it is, event on landed. And we're going to do the same thing. We're going to call the land event on the Parkour movement component. Now if you'll recall, first step is to stick to the wall. In order to do that, we'll need to shoot a raycast left and right of the character. And if it hits a wall, then we'll stick to it. So we're going to create a new custom event, call it wall run update event. And we'll call this right on our initialize function. We're going to set a timer, which calls this event. It's going to call it on a loop every 0.02 seconds. All right, so now we're going to create a function called wall run update. This is going to be called every 0.02 seconds. Just need to call it here. We're going to need the start and end point of our ray traces. Start point is just the character's location. The end point we're going to have to calculate. So I'm going to make a new macro. Call it wall run end vectors. Now in here, we're going to need the character's location. And we're also going to need the character's right direction and forward direction. So the reason we need the forward vector here is so that we can draw our raycast slightly backwards instead of straight and off to the side. This gives us some wiggle room so that the character can rotate their camera while they're shooting and they won't have to worry about falling off the wall. So now that we have our vectors, we can go ahead and start to calculate the left and right endpoints. I'm going to start on the right side and I'm going to multiply my right vector by 75. That'll give us a length of 75 for the raycast. And I'm also going to multiply the forward vector by negative 35 just so that it's pointing slightly backwards to give us that wiggle room. Now we just need to add these three together. And we'll have our right endpoint. Now for the left, we just need to copy this over. And we just need to change this value here to negative 75. And that'll give us our left vector. Now we need a function that can take in these values and cast the ray and also perform the wall run movement. So we're going to create a new function called wall run movement. And in here, we're going to call line trace by channel. This will allow us to do the raycast. We're going to pass in a start and end vector, and we're also going to need the direction in a float. We're going to use that later. So we need to split this struct and see if we get a hit. If we do, we're going to need to look at the normal of that hit and verify that it's a wall and not the ground or some kind of slope or anything. We want to make sure that it's, perpendicular to the ground or at least close to that. So for this, we're going to make a new macro called valid wall run vector. Now in here, we're going to pass in a vector, and it's going to be the end vector. Now with this, we're going to want to break this, and all we really need to know is if the Z component falls within a certain range that we define. And I have this already figured out. So this will work for us, for our use case. So from negative 0.52 to 0.52, and it will return true if this Z component falls within these values. And we can also output the vector as well. So now that we have that, we can go back to this and we'll make another branch and we'll look at the out hit normal and we'll make sure that it's a valid vector. All right, so if it's a valid vector, we're actually going to save it. So let's promote this to a variable and save it as wall run normal. And so now once we get to this point, we'll be able to do more with this vector. So now we have this saved. We should also check to make sure that the character is falling. So we can do that by getting the character movement and just checking if it is falling. And we'll check that. Now the next step will be to actually stick the character onto the wall. In order to do that, we're going to need to launch the character towards the wall. And we're not going to use the wall run normal, we're actually going to use the opposite of that. So we can make another macro for that and call it player to wall vector. So this is just going to return a vector and it'll be from the player to the wall. So we'll output a vector. And we'll need the actor location. We'll also need the wall run normal here. Now we're going to subtract our location from the wall normal. Now we don't want to continually push the character onto the wall. We want to stop once we get close enough. So to do that, we're going to get the length of this vector, and we're actually going to multiply the wall normal by it. And this is the vector that we return. So as we get closer to the wall, the player will be pushed less and less. With this, we should be able to stick the character to the wall. So we'll go back to the wall run movement, and we'll use this macro that we made as the launch velocity. We're also going to need to launch the character forwards so that they stay on the wall and they move in a consistent way. So we're going to launch the character again. This time we're going to override the XY movement, and we're going to calculate the forward direction. So for this, we actually need the wall run normal, and we're going to need the cross product of that and up, so Z1. Now this cross product will give us either forwards or backwards, depending on what wall we're on, if we're on the left or the right side. So that's where the wall run direction comes in, actually. So we're going to use that. And we're going to make a new variable for wall run speed. Now we're going to multiply our speed by the direction. And we'll use that as a multiplier for our forward vector. Now we plug this into the launch, and now what this will do is move our character forward. Now if we want to make it like Titanfall, we can override the Z as well, and then you'll run in a straight line on the wall. That's how a lot of games do it. So we'll call this wall run gravity. So if wall run gravity is not true, then we won't use gravity. But if you want realistic gravity to work while you're wall running, then you can go ahead and leave this turned on. We're going to set the wall run speed to a default value, say 850 units. And we can go ahead and return true here. So this will tell us that we are on the wall and it was successful. Now we need to go back and actually return false wherever the wall run failed. So if we didn't hit a wall, or if it wasn't a valid wall, or if the character wasn't falling. So this will stick the character to the wall, and this is going to move the character forward. So now that we have that set up, we can go back to our wall run update function and call our wall run movement. We'll start on the right side Our direction is going to be -1, and we're going to pass in our start and end vectors. So that's going to be, the start vector is going to be the actor location, and the end vector is going to be our right end point. So if we do hit the wall on the right vector, we're going to go ahead, we're going to actually create some new variables here. So want a variable, see if we're wall running in general. And then we want 2 more variables, one for the right side and one for the left side. So we'll say we are wall running and we're on the right wall and we're not on the left wall. So if we go back to our outline here, we'll see that we did stick to the wall. Now we need to drop the gravity. So to do that, we're going to smoothly interpolate the gravity of the character to our target gravity. So we're going to get the character movement, get the gravity scale, and we're going to interpolate so the current gravity is our current gravity, and then the target, can promote this to a variable, call it wall run target gravity. And we can set this by default to 0.25. Now we need our delta time, world delta seconds, and for the interpolation speed we can just set it to 10. And we're going to set the gravity scale of our character to this value here. Next we'll do the left side. So we're going to branch off of here and we're going to check if we're already wall running on the right side. And if we're not, that means we're not wall running at all. So we're going to have to check the left side. We just copy this over. And instead of the right side, we'll do the left side, and then we'll change our direction to 1. Now we can copy this up here. And instead of wall running right, we're going to be wall running left. And then we're also going to change the gravity. So that looks good. The next thing we need to do is make a function to reset everything basically and end the wall run. So we'll call this wall run end. We're going to set all these booleans to false. And we're going to reset the gravity. To do that, we'll get the gravity scale. We're going to set the gravity scale to the default gravity. And that's it. So now we can go back to our wall run update and we can call wall run end. So this is basically the case of we're wall running to our right and we're not doing that anymore. And this is the case if we're not wall running to the left or the right. Now, if we're booted from the wall run, we're not going to want to allow the character to continue checking right away. So we're going to create a new variable called wall run suppressed. And we're going to make a function called suppress wall run. Now in here, we'll set this to true. And we'll pass in a delay so that we can set this back to false. So what we'll do is we'll set a timer by function name, and we'll call this function reset wall run suppression. So we're going to suppress wall running, and then bring it right back. So in the wall run end function, we can also do the same thing here. We'll add an input for the reset time, and we can pass that into the suppress wall run function. For this to work, we're going to need to create a custom function with this name so that we can reset it. So go back to our event graph, make a new event, reset wall run suppression, and then we'll just set this to false. We also should clear any other timers so that if any other function calls this, it's stopped. So we'll just paste that back in there too. So now we'll come in here, clear any other timers from anywhere else, and just set this back to false. Now we go back to our wall run update function and we set the reset time to 1. So that way, if you're booted from a wall, you get about a second, and that gives you enough time to land and try again. So we just finished dropping the gravity. Next up is tilting the camera. So we're going to go back to our event graph, and we're actually going to use the event tick here, make a new function called camera tick. And in here, we're going to tilt the camera differently depending on if we're wall running left or right. Here we'll make a new function called camera tilt. And here we'll pass in the target roll. Now we're going to use this to interpolate. So we'll call rInterp2, split this, and we're just going to interpolate the roll, and we're going to keep all the other values the same. So now to get the control rotation for our character, we're going to need the character, we're going to need the controller, and we're going to need to find the control rotation. Now with this, we can break this and just pass in the pitch and yaw. And our current rotation is just going to be our control rotation. So we'll interpolate from our control rotation to this new rotation based on this target roll. Now we'll get our controller again, and this time we're going to set our control rotation to this new rotation. Lastly, we need to set our world delta seconds here, and we also will set this speed to 10. Now that we have that, we'll go back to our camera tick, and we're going to call camera tilt. For the left side, it'll be 15, and for the right side, it'll be -15. Now, if we're not wall running at all, we can just call this and set it to 0. Now we go back to the event tick, and we can call our camera tick function. So let's test it. And it's working. Now we do have one problem. We need to be able to jump off of the wall. So to do that, we go into our jump event here. And we're going to make a new function called wall run jump. Now again, We only want to call this if we're wall running. So we're going to check that first. And if we are wall running, then we want to end the wall run. We'll make this a shorter time. That way you can string wall jumps quickly. Now we want to launch our character. We're going to launch him up and off of the wall. So we need to override the Z. And we can actually make this a variable. So we'll promote this to a variable. Call it wall run jump height. I'll set this to 400. And then for the launch velocity for X and Y, we'll calculate that based on the wall run normal. So we'll break this. And we can multiply X and Y by a multiplier. So we'll promote this to a variable and we'll call it wall run jump off force. And we can do that for Y as well. So that's going to be our X and Y values here. So not only will we jump upwards, we'll also jump away from the wall we're on once we hit jump. So now we need to call this function in our jump event. We should also end the wall run event if we land. So we can call wall run end. We can reset it right away. And we can set wall run suppressed to false. We also need to make sure that we're not calling the wall run update if wall run suppressed is true. So this will allow us to jump from the wall without it pulling us right back. Now we can set our jump off force to 300. We also need to make sure that the wall run end event isn't called all the time because it's going to keep resetting the wall run. So we want to make sure it's only called once if wall running is true. So we stuck our character to the wall, we dropped the gravity, and we tilted the camera. Now we should have a fully functional Titanfall style wall running. So let's test it. And it's working. And you can shoot, you can aim around. Let's try the right side. Working the same way. Now, since we did set up the gravity, we can go ahead and enable that here. If you want like a more realistic wall run, go ahead and go up into the wall and you'll see that you'll have an arc now. It won't just go on forever. So that's an option to you as well.